question number 1b. The acid dissociation constant, the Ka of a weak acid Ha has a value of 2.56 times 10 to the power of negative 4. Calculate the pH of 4.25 times 10 to the power of negative 3 molar solution of Ha. So this is a rather straightforward question. Given to you is the value of the Ka and the concentration of Ha. So the first thing that you need to do is to write the equation. So given to you is the chemical reagent is the Ha. So Ha when it dissociates, so Ha will form H plus and A minus. Alright. The next thing that you need to do is you need to create the ICE diagram. So I, C, E. The initial concentration of Ha given in the question is 4.25 times 10 to the power of negative 3. So 4.25 times 10 to the power of negative 3. At first, there's no product, so 0, 0. Since this is a weak acid, so at change, it will be negative X, positive X, positive X. So at equilibrium, it should be 4.25 times 10 to the power of negative 3 minus X, X, and X. Right. The next thing that you need to do is you need to calculate the value of X, because given to you is the value of Ka. So Ka is equivalent to X times X, whatever in the product, divided by the reactant, 4.25 times 10 to the power of negative 3 minus X. Right, whereby the value of Ka is equivalent to 2.56 times 10 to the power of negative 4. So it's going to be X squared divided by 4.25 times 10 to the power of negative 3 minus X. Okay, what we are going to do now is we are going to do the approximation method. So we are going to omit this X. So once you omit this X, means that you will get 2.56 times 10 to the power of negative 4 should be equivalent to X squared divided by 4.25 times 10 to the power of negative 3. So moving on to that, you should get the value of X is equivalent to the square root of 1.088 times 10 to the power of negative 6. So you should get your X equivalent to 1.0431 times 10 to the power of negative 3. Right. So this is the first section for this question. Alright. So from the previous calculation, we get the value of X is equivalent to 1.0431 times 10 to the power of negative 3. Alright, so remember, during our calculation, we are using the approximation method. So we need to know the validity of this value of X. So we need to do the test. So the test is equivalent to the value of X that you get. So 1.0431 times 10 to the power of negative 3 divided by the initial concentration, which is 4.25 times 10 to the power of negative 3 times 100. Alright, so if you get the test below 5%, then this value is valid. So we are just going to check. For this one, what we get is actually 24.5435%. So obviously this is bigger than 5%. So the value of X here is not approved. Okay. So since it doesn't approve, so what you need to do is you need to calculate the new value of X. So Ka is equivalent to X squared divided by 4.25 times 10 to the power of negative 3 minus x, right? So we are going to use the value of x that you get, the first one, in here. So you should get x squared. The value of Ka, you need to follow the same value of Ka that given to you in the question. So the value of Ka is the same, 2.56 times 10 to the power of negative 4. So you will get the x squared is equivalent to 8.2097 times 10 to the power of negative 7. Alright, so next is your x. So your x, you should do just a square root of this one. So the value of x should be 9.0607 times 10 to the power of negative 4. So this is your actual value of x. So we need to refer back to our ice diagram. So the value of x is actually equivalent to your value of H plus, right? So x equivalent to the H plus. So x equivalent to the H plus, it means that when you want to calculate the pH equivalent to negative log H plus. So indirectly saying that the value of your H plus is this. So you should be able to get the pH. So pH is equivalent to negative log 9.0607 times 10 to the power of negative 4. So you should get the pH of this particular solution is 3.0428. So this is the final answer. So it figures, right? The pH is lower than 7. So it is indeed an acid.